So it's on to Python. In this video, I'm going to give you guys some general background on computer programming and also the components that are involved specifically in programming in Python. So there's some vocabulary, some terminology that we should make sure that we're all familiar with before we get started. One, arguments. We talked about this a little bit when we were discussing Unix, but these are the values that are sent into a program at the time it is run. So these are values that you can use to affect the behavior of a program. We're going to be talking about code, and code can be treated both as a noun and as a verb. It can either be a program or a line of a program, or it can be the process of writing a program. When I say I'm going to execute something, it means I'm going to run a program. If I'm talking about a function, this is a subprogram that can be called repeatedly to perform a task within a program. It's also sometimes referred to as a method. I will talk about parameters, and while programs have arguments, typically we think of functions having parameters. So this is going to be a value that we can send into a function. I'll often use the word parse, especially when programming in Python, and this means to extract particular data elements from larger blocks of text. Sometimes I'll refer to a return, and what a return is if I have a function and I run that function, it's the act of sending back a value from that function. I think the most basic way to think about this is like when you hit the cosine key on your calculator, right? It's going to return a value. So if you do the cosine of x, you're going to get y. A statement is going to be a line of a program that performs a specific operation. And lastly, we have a comment, which is an internal note on program code. So this is going to be some annotation within the program that's going to allow us to understand what the program is actually doing. So, Python. What is Python? Why Python? Well, Python is a relatively new programming language and has grown incredibly rapidly in terms of its use, especially within the sciences. Originated back in about 1991. And why is it so popular? Well, one, it's got a good clarity of code. It's relatively easy to read and understand as opposed to, say, something like Perl. It's very good at manipulating text. It supports a wide range of different programming types. Object-oriented programming, which is one of the sort of gold standards of programming techniques that's implemented sort of broadly in industry and in the sciences, as well as structured and functional programming, which I'm not going to go into a long thing on the nature of all these different types of programming. The point is simply that Python can do a lot of these different types. For your intents and purposes, it doesn't really matter if you know what they all are, but they do all have certain purposes and strengths and weaknesses that may become helpful as you move through your career as data scientists. But for now, you just need to know that Python's a good tool. The big thing about Python is it's actually a very accessible tool, and it is fully functional despite being accessible. So it's easy to use, and it's got all the pieces you want. It's applicable. You can use it to reformat. It's got a high ability for applicability. You can reformat and organize data files very easily in it. It can perform all kinds of mathematical and statistical analyses. You can use it for visualizations. You can use it for basically anything that you want to do within the sciences. It's a very powerful language. And if there's an old poem called the Zen of Python, and I think it's got some nice pieces in there about why we all like Python so much. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. And readability counts. All good things to keep in your heart as you are coding in Python. A few other terms. We're going to talk a lot about variables. We've talked about them a little bit so far, right? Those $ entities that we used in Unix. But in this case, a variable is going to be a name that holds a value, and that value can change. That name should be chosen specifically to indicate the content that it's going to hold, right? And generally, we don't want to include punctuation, and it should never start with a number. All variables not only have names, but they also have types. And this tells us what kind of content that variable contains. And then all variables also will have values. And this is the content that it actually holds. So it's going to have a name, it's going to have a type, and then it's going to have an actual value. There's some other concepts associated with variables, such as things like scope, but I'm not really going to go into a lot of detail initially with scope, as it's just going to slow us down as we try to power our way through Python. So I think one of the things to understand is this course is called Practical Computing for Scientists, and that means that I'm not going to spend a lot of time going into a lot of the specific details about some of the programming, but you do have the opportunity then to further your own education and pursue some of these topics in further depth, and it can be really useful to do so. So I encourage that. But we'll set the table and we'll get it all, and we'll serve the first course, and then it's going to be up to you to cook the rest of the meal. So what types of variables are there? There are integers, which are whole numbers, sometimes referred to as longs as an alternative. They're a slightly different type. There are floats, and these tend to be really large numbers, especially numbers that have decimals, often also referred to as doubles. There are booleans. These are true-false types. And then there are string types. And these are your basic alphanumeric words, so to speak. And you can see examples of these things over on the right-hand side, right? An integer, a float, a boolean, true or false, or a string. A string is always going to be bracketed by either double or single quotation marks. In addition to variables, just like in Unix, you'll find that there are operators. And operators basically are variables in action. So programs need to do stuff, and to do stuff, we actually need operators or functions, right? So if we think of variables as the nouns, operators and functions are going to be the verbs. And so there's some very standard, straightforward types of operators, things like mathematical operators. I think we could all understand what a plus and a minus sign do. But there are more complicated ones, such as the mod, which just returns the remainder after you do division. So if I was to do 3 mod 2, I would get 1, right? Or 5 mod 2 in the case that's there, and I would get a 1 as well, right? Because 2 would go into 5 2 times with 1 left over. There are also comparative and logical operators. These are for making comparisons of variables. And when they come back, this is your equals and greater than and not equal to, etc. And when the value that they return is either true or false. And then the logical variables are typically things like just, your ands and ors and nots. Notice that there are different ways to do these types of operators, and that especially for the logicals, there's multiple ways that you can write them. You can just use the word and, or you can use the ampersand sign or the double ampersand. In addition to variables, there are other entities in programming languages that we refer to as data structures. And there's lots of different types of data structures. I am just going to introduce 2 types of data structures. Okay? And so these data structures, the 2 types I'm going to introduce to you, one of them you should be fairly familiar with, which is the idea of a list. right? Remember when we were looping through lists of items in Unix? Well, it's the same thing. It's just that now we have a variable that is of the type list that's going to hold information in it, right? To call a list, you're going to use these square brackets to identify something as a list. And I can either create an empty list or I can create lists with things in them, right? And then there are certain functions that are associated just with lists, certain things that only lists can do. Now notice I can have string type variables and I can have integer type variables in the same list. The list itself doesn't care. It just needs to have an item at each position. And again, it's written by putting square brackets and then a series of items separated by commas. In addition, you can see over here there are some specific commands that you can associate with lists. You can figure out how long a list is. You can concatenate lists. You can multiply a list and make it a list of repetitive elements. You can test to see whether or not there's something is in a list, and you can iterate through a list, just like we would expect to be able to do in Unix. There are other things similar to lists that we can use, such as arrays or tuples or anything of that sort. But there are other types as well, and one of those types is a dictionary. And a dictionary is very similar to what you might imagine a dictionary, the book version of it, is. One of the differences, though, is that what we find in a dictionary isn't necessarily ordered in alphabetical order, like a dictionary. What it is it's an ordered list of values with keys associated with them. And with every key, you don't necessarily only need to have one option. You can have multiple entries per key. And one thing about a dictionary is it doesn't change. It's immutable. It's defined by when we make an empty dictionary, what we do is we create something that's got these little curly brackets, a word with these curly brackets. And if we want to add an item to that list, we have to identify the key by putting it in square brackets and then say what is associated with the key. What is the value that's associated with this key? So in this case, we have some GPS coordinates associated with the name of a city in Alaska, right? So this is the key and this is the value. And what that means is that when we go and we want to look up something in our dictionary, what do? We give it the key, Kodiak, Juno, Barrow, and it will return the value associated with that key. We can also write this longhand. This is a way to add one at a time. We can write it longhand where we use the curly brackets. We put the key before a colon and then the information that's associated with that key, which in this case is a list of doubles or floats. And so this shows you which parts are the keys and which parts are the values. So that's the most basic introduction to the simplest components of Python. And so now I'm going to take a little break and show you guys how to use Python. And then now I'm going to take a little break and show you guys how to use an IDE called Jupyter to actually execute and generate and run Python code.